Good day everyone, I am John Mark and Bautista and my topic for today is about energy equations. So first, energy and health. What is the energy? The energy possessed by flowing fluid consists of the kinetic and potential energy. So first, let us define what is head. Head is the amount of energy per pound of Newton of fluid. Next, potential and kinetic energy are two forms of energy that can be converted into each other. Potential energy can be converted to kinetic energy and vice versa. You now know that potential energy is position relative and kinetic energy is motion relative. Kinetic energy, meaning the ability of the fluid mass to do work by virtue of its velocity. Karon ang formula karon. Kinetic energy is equals to 1/2 mass times velocity squared is equals to 1/2 times weight over gravity times velocity squared. Tapos next ay kinetic of velocity head is equals to kinetic energy all over weight is equals to velocity squared all over 2 times gravity. Next, kinetic for circular pipe of diameter d flowing full, anong formula ay v squared is all over 2g is equals to 8q squared all over pi squared times gravity times d to the 4th power. Next ay elevation energy, potential energy, meaning the energy possessed by the fluid by virtue of its position or elevation with respect to the datum plane. Anong formula ay formula ay sa elevation energy is equals to weight times z is equals to m times g times z. Elevation head matahay is w times z all over w is equals to z. Pressure energy, potential energy, meaning consider a closed tank filled with a fluid which has a small opening at the top. With a pressure at the top, the fluid practically will not flow. The equivalent pressure head for a pressure of P is P all over Y. Hence, the pressure energy is equivalent to y gali guys ay ano nga meaning ko na imo hay ito wait lang tag y galingan guys ay alam kan ka na weight density. So ang formula sa pressure energy is equals to W times P all over weight density. Sa pressure head naman is equals to W times P all over pressure weight density all over W is equals to P all over weight density. Next, where Z is equals to position of the fluid above positive or below negative the datum plane. P is equals to fluid pressure and V is equals to mean velocity of flow. X. Total flow energy E, meaning the total energy of head in a fluid flow is the sum of the kinetic and potential energies. It can be summarized as formulas. Total energy is equals to kinetic energy plus potential energy. Total head naman is equals to energy is equals to velocity squared all over 2 times g plus p all over weight density plus z. Next, power and efficiency. Power is the rate of which work is done. For a fluid of unit weight density time is equals to Newton all over meters cube and moving at a rate of q is equals to cubic meter per second with a total energy of meter. The power in Newton meter squared second is equals to joule all over second, or what is power and efficiency. Note, 1 horsepower HP is equal to 746 watts. 1 horsepower HP is equals to 500 50 feet lb per second. 1 watt is equals to 1 newton meter per second or equals to 1 joule per second. Formulas for power is Q discharge times weight density times energy. For efficiency, N is equals to output all over input times 100. Bernoulli's energy theorem. The Bernoulli's energy theorem results from the application of the principles of conservation of energy. This equation may be summarized as follows. An example at Bernoulli's figure. Parang pipe more on pipe. In physics, the concept that as a speed of moving fluid, liquid or gas increases, the pressure within the fluid decreases. Originally formulated in 1738 by Swiss mathematician and physicist Daniel Bernoulli, it states that the total energy in a steadily flowing fluid system is a constant along the flow path. An increase in the fluid speed must therefore be matched by a decrease in its pressure. Energy equation without head loss. If the fluid experiences no head loss in moving from section 1 to section 2, then the total energy at section 1 must be equal to the total energy at section 2. Neglecting head loss in fluid flow, the values that we get are called ideal or theoretical values with reference to the figure on the next slide. Makita natin na hinduna sa ako niya example number 2. Formulas. E sub 1 is equals to E sub 2. Velocity 1 squared all over 2 times gravity plus P sub 1 all over weight density plus C sub 1 is equals to velocity sub 2 squared all over 2 times gravity plus P times weight density plus Z sub 2. Ato may nga graph, figure na ginapakita. Next, energy equation with head loss. Considering head loss, the values that we can obtain are called the actual values with reference to the figure. Para the figure na nakaroon. Kung kain na hay, bukan na matutod-utod nga lain, makanin utod-utod yun. So, formulas na hay, E sub 1 minus HL1 to 2 is equals to E sub 2. Velocity sub 1 squared all over 2 gravity times gravity plus P sub 1 all over weight density plus Z sub 1 is equals to velocity sub 2 squared all over 2 times gravity plus P sub 2 all over weight density plus Z squared plus HL1 2 dapat to. Mali, sorry. So, next equation, energy equation with pumped. So, makita na po karay, head added. Nag-add kita head. Pump is used basically to increase the head, usually to raise water from lower to higher elevation. The input power P input of the power pump is electrical energy and its output power P output is the flow energy. So, hara na formula, makita mo na ito. So, nagdugang karahay, output power of pump is equals to discharge times weight density times head added. Next, energy and hydraulic grade lines. Hydraulic grade lines, HGL, also known as pressure gradient. Hydraulic grade line is the graphical representation of the total potential energy flow. It is the line that connects the water levels in successive piezometer or piezometer tubes placed at intervals along the pipe. Its distance from the datum plane is P all over weight density plus Z. Next, energy and hydraulic grade lines, or hydraulic grade lines HGL characteristics. First, HGL slopes downward in the direction of flow, but it may rise or fall due to changes in velocity or pressure. Second, for uniform pipe cross-section, HGL is parallel to the EGL, or energy grade line. Last is for horizontal pipes with uniform diameter. The drop in pressure heads between any 2 points is also equal to the head lost between these points. Next, energy and hydraulic grade lines, or energy grade lines, or EGL. Energy grade line is a graphical representation of the total energy of flow, the sum of kinetic and potential energies. Its distance from the datum plane is velocity squared all over 2 times gravity plus p all over weight density plus z. Hara ng characteristics, so may 4 mo. First is EGL always slopes downward in the direction of flow, and it will only rise with the presence of a pump. Second, for uniform pipe cross-section, EGL is parallel to the HGL. Third, EGL is always above the HGL by an amount equal to the velocity head. Velocity squared all over 2 times gravity. And lastly, neglecting head loss, EGL is horizontal. Always remember that. So here an illustration is EGL, showing the behavior of energy and hydraulic grade lines. So halimaw, kung may libro ka mo, makita nyo man mo sa libro ninyo. Si-zoom lang ninyo dahil ka. Next, first example natin. Water flows through the turbine shown at a rate of 0.386 cubic meter per second. The pressure at the A and B are 161.2 kPa and negative 19.6 kPa respectively. How many kilowatts are delivered by the water to the turbine? So, haraan na figure karon. Ano itong formula? So, ito man sa given ay makita natin ito nga discharge, which is 0.386 cubic meter per second, ay hara ng formula to sa power discharge times weight density times energy. So let's solve. Do discharge pagit na nga formula hay A times velocity sub A. 0.386 is equals to pi over 4 times 0.35 squared times velocity of A. So velocity of A is equals to 4.01 meter per second. So para mabuo man do bingarahay ato malay mo substitute to A nga ron. So next dahil hay i-substitute din natin no mga given yun natin sa formula nga to sa baba, which is the velocity sub A squared all over 2 times gravity plus P sub A all over weight density plus Z sub A equals V sub B squared all over 2 times gravity plus P sub B all over weight density plus C sub B plus HE, which is the head extracted. So 4.01 squared all over 2 times 9.81 plus 161.2 all over 9.81 plus 1.08 is equals to 0.77 squared all over 2 times 9.81 plus 19.6 all over 9.81 plus HE. So HE do ang unknown nato para do head extracted, which is the sabat naton hay 16.30 meter. Saga siguro gali kay natag sa question which tag 19.6 dapat positive gali to. I'm sorry for that. So the aton nga power is equals to 0.386 times 9.81 times 16.30. So formula sa ibabaw, P is equals to 61.72 kilowatts. Final answer. Haraman also sa picture do aton nga ako nga solusyon kay ina naging obra. Next example and last example. Assume the conduit shown has a diameters of 300 mm and 400 mm at section 1 and 2 respectively. If water is flowing in the conduit at a velocity of 5 meter per second at section 2, find the following: A. Velocity at section 1, B. Flow rate at section 1, C. Flow rate at section 2, D. Weight flow rate, and lastly mass flow rate. So hanato nga illustration karon sa tunga gaagi do atong fluid. So ato solution yung kita sa A hay atong nga equation formula gali hay discharge is equals to A times velocity. So atong nga sabat hay pi all over 4 times 0.45 in convert natin na millimeter to meter squared times 5 is equals to the discharge natin hay 0.795 cubic meter per second. So discharge is equals to A V sub 1 matadayon. So do Q sa ibabaw kay ina hay aton is substitute sa Q. So idam sa discharge sa idarom. So 0.795 is equals to pi over 4 times 0.3 squared V sub 1, velocity sub 1. So velocity sub 1 naton hay 11.25 meter per second. So gihambangan ni kay ina ako kay ina matong aming may parehas kita di kato sa ang gihambang nga report. So B is equals to 0.95 cubic meter per second. Sa note dun kay ina nga mega parehas giman. Tapos do C naton hay 0.795 human cubic meter per second, and sa D matahay so nakita ko ang gali ko mat parehas. So energy equation without head loss gali amount di katugyan ba kay na if the fluid experiences no head loss in moving from section 1 to section 2, then the total energy at section 1 must be equal to the total energy at section 2. Neglecting head loss in fluid flow, the values that we get are called ideal or theoretical values with reference basta sa figure. So ato dayon. So letter D hay 0.795 cubic meter per second times 9.81 kilonewton all over meter cubic meter. Baligi ano ron? Unit. So ano sabat is 7.80 kilonewton per second. The letter D galingara hay weight flow rate, diba? So letter E yun kita, which is the efficiency. So 0.795 times 1000 is equals to 795 kilogram per second. Buang gila mat efficiency. Mali. Nagali, the letter D gali naton hay mass flow rate. So anong formula karnay? Mass is equals to P times Q. Do P hay mass density in kilogram or meter cube all over meter cube or slugs per feet cube. Tapos do weight flow rate matahay sa letter E. which is anong formula hay weight is equals to weight density times Q nga discharge. So 1,000. So atong sabat is 795 kg per second. Parang solution akon karon. And next, thank you for listening. Happy Hearts Day everyone. That's all for today. Thank you.